Okay, so today we are going to find the area of compound figures, sometimes called irregular figures. Now, when we do that, you'll notice that these shapes, the ones that you see above there, are made up of different shapes kind of put together. That's why we call them compound. And they're irregular because not all of the side lengths are the same. So we've talked about area this week, and I just want to review with you quickly some of the different formulas for area that we've discussed. So we have talked about the area of a rectangle, and we know that the area is the base times the height, sometimes called the length times the width. We've also talked about the area of a triangle, and we found through our activity lab that the area of a triangle is the base times the height divided by 2. We've also discussed the area of parallelograms, and again, that being the base times the height. And finally, we've also talked about the area of trapezoids. And we discussed how the trapezoid has not one base, but 2 bases. And it's our job to find the average of those 2 bases. So that's why we add the 2 together and divide by 2 before we multiply by the height, so that we can find the average size of the 2 lengths of the bases. So now that we've reviewed these, let's take a look at how we are going to find the area of these shapes up here and what type of shapes they're actually composed of. Okay, let's take a look at this first shape. So you might notice that it sort of looks like an L, but if we want to, we could cut this shape into 2 different shapes. What 2 shapes should we cut them into? I see a square, and then I also see a rectangle. So I know that the area of this square here at the top is the same as the area of a rectangle, which is base times height, or length times width. And so I can find the area of this square by multiplying. And I know that the area is 9 centimeters squared. Now I can look at the area of the bottom portion of this compound figure. Now, what will be the base and the height of the rectangle? We can see that the base is 6 centimeters and the height is 3 centimeters. So we know that the area of the rectangle is 18 centimeters squared. Now, if we want to find the total area of the compound figure, what do we need to do with the 2 areas? Yeah, so we can write the number sentence, 9 centimeters squared plus 18 centimeters squared equals the total area of the compound figure. And we get 27 centimeters squared. Okay, now let's take a look at this shape. What 2 figures can we cut this shape into? Well, I can see this little house shape. I can cut it into a triangle on top and a rectangle on the bottom. So if I want to find the area of the triangle, what's the formula again? We know it's base times height divided by 2. So now I just need to figure out, well, what is the length of the base? What is the height of the triangle? Do I have enough information here? So I can see that the base of this triangle is the same as the length of the rectangle below it, and that would be 18 meters. And the height of the triangle is 9 meters. And then I'm going to divide that by 2. Feel free to use your calculator. To find the area of the triangle, you should have 81 meters squared. Now, that's not the entire shape, I know that I also still have this rectangle here beneath the triangle. So I need to find the area of the rectangle as well. So I want to find the area by multiplying the base times the height. And what is the length of the base of this rectangle? You can see it's 18 meters and the height is 14 meters. I can use my calculator to multiply the two together. You should have 252 meters squared. So now what's the number sentence that I could write to find the total area of the compound figure? I have the area of the triangle and the area of the rectangle. So I know the total area of the compound figure is 81 meters squared plus 252 meters squared. So the total area of the compound figure is 333 meters squared. Now, let's examine the figure that we see here. This is also a compound figure. It's made up of more than one two-dimensional figure that we've looked at already this week. So how would you divide this shape? I can see a triangle here on top, and then I see possibly a square, but I'm sure I can say rectangle beneath it. So again, how do we find the area of the triangle on top? Remember, it is base times height divided by 2. So now I just have to figure out, well, what is the length of the base? What is the measure of the height of this triangle? The length of the base is not exactly given to us. We have to figure that out. We know that this part of the triangle right here has a measure of 10 inches. We also know that the triangle extends in both directions an additional 4.5 inches on both sides. So I can find the total base by adding 10 inches plus 4.5 inches plus an additional 4.5 inches. That's a total base length of 19 inches. So I'm going to fill that into my number sentence. 19 times the height. The height is given to us. It is 15 inches. And then I know I'm going to cut that in half and divide it by 2. And so the total area for the top part of the compound irregular figure is 142 and 5/10 inches squared. So we know this is only part of the compound figure. Now we need to find the area of the figure beneath it. So if I take a closer look at that figure, I notice that the base and the height have something in common. So we might even be able to say that this figure is actually a square, because I can see that both the base and the height measure 10 inches. And so therefore I know that the area of the square, which is 10 squared, equals 100 inches squared. And so now to find the total area of the arrow or the compound figure, I can write the number sentence 142 and 5/10 inches squared plus 100 inches squared. That's a total of 242 and 5/10 inches squared. I hope that you now have a better understanding of what compound figures are and how to determine the area of those.